Close your eyes and feel the ground beneath you. Right now, as you settle into stillness, you are resting on one of the greatest libraries ever written. This library has no books. It has no shelves. Instead, it holds its stories in stone and soil, in the patient layers of rock that have been collecting tales for millions of years. The earth remembers everything, every raindrop that has ever fallen, every footstep that has ever pressed into mud, every fire that has ever burned on a long ago night when your ancestors looked up at the same stars you see today. All of these moments live on in the geological record, written in a language that scientists are only now beginning to read. Tonight, we will explore how stones and sediments hold the story of human migration, how rocks can tell us where people walked thousands of years ago, how the very ground reveals the paths our species took as we spread across the world, following rivers and coastlines, crossing mountains and deserts, always moving, always searching for home. Imagine yourself walking across an ancient landscape. The year is 50,000 years ago. There are no roads, no cities, no maps, just you and your family group, moving across a world that looks nothing like today. The sea level is lower. Ice sheets cover lands that are now green. Rivers flow in different directions. Mountains stand where plains exist now. You are part of the greatest journey in human history, a slow migration that will eventually take your descendants to every corner of the earth. But here is the remarkable thing. As you walk, you leave traces. Not just footprints in the mud, though those matter, too. You leave behind something much more lasting. You leave behind evidence that will survive in rock and mineral, in the chemistry of soil and the arrangement of stones. When you make a fire, you change the magnetic properties of the ground beneath it. When you shape tools from volcanic glass, you create a trail that leads back to distant volcanoes. When you build shelters near rivers, you become part of the sediment layers that will form tomorrow's rock formations. You are writing a story in stone without knowing it. The earth collects these traces like a patient librarian. Wind and water sort them into neat layers. Time compresses them into rock. Heat and pressure preserve them for thousands of centuries. And then, much later, when curious humans learn to read this geological language, your story emerges again. This is how we know that humans first walked out of Africa. This is how we trace the paths they took through Asia, across land bridges that no longer exist, to islands that were once connected to mainlands. This is how we follow their journey to Australia, to Europe, to the Americas. Not through written records, because writing came much later. Not through stories passed down, because memory fades, but through the patient testimony of rocks. Consider the volcanic glass called obsidian. This black sharp stone forms when lava cools quickly. Each volcano creates obsidian with its own unique chemical fingerprint, like a signature written in minerals. When ancient people traveled hundreds of miles to collect this valuable stone, they carried that signature with them. Archaeologists find obsidian tools far from their volcanic sources. By matching the chemical fingerprint of the tool to the fingerprint of the volcano, they can map ancient trade routes. They can see how ideas and technologies spread along with the people who carried these glassy treasures. Every piece of obsidian is a message from the past. It says, someone walked here. Someone valued this stone enough to carry it across great distances. Someone had the knowledge and skill to shape it into tools. Or think about river terraces. These are the ancient banks of rivers that once flowed at different levels. As rivers cut deeper into their valleys over thousands of years, they leave behind these stepped formations, like the rings of a tree showing its age. But river terraces hold more than just the history of water flow. They hold the artifacts and remains of people who camped beside those ancient rivers. Each terrace is a different time period, a different chapter in the story of human habitation. By studying which terrace contains which artifacts, geologists can determine exactly when people first arrived in a river valley. They can see how human settlements changed over time. They can trace the spread of new technologies and the paths of ancient migrations. The Earth has been keeping these records for us all along. We simply needed to learn its language. This language is written in layers of sediment that accumulate, grain by grain. It is written in the slow drift of continents and the rise and fall of mountain ranges. It is written in the advance and retreat of ice sheets that opened and closed the corridors through which our ancestors traveled. Learning to read this language has taken human civilization thousands of years. We needed to develop chemistry to analyze the composition of rocks. We needed to understand physics to decode the signals locked in magnetic minerals. We needed to master mathematics to calculate the age of geological formations. But now, finally, we can hear what the Earth has been trying to tell us. The story it tells is one of incredible human resilience and adaptability. It shows us a species that could read the subtle signs in landscape and weather, that could navigate by stars and ocean currents, that could survive ice ages and volcanic eruptions and rising seas. It shows us people who are not so different from you. Tonight, as we begin this journey together, remember that you are part of this same story. The same curiosity that drove your ancestors to explore unknown lands now drives scientists to explore the unknown territories of deep time. And, beneath you always, the patient Earth continues writing, recording your footsteps, collecting the traces of your time, adding your chapter to the great stone library that will outlast us all. In the next part of our journey, we will learn how scientists read the oldest pages of this library, where the story of human migration begins to unfold in the careful layering of ancient sediments. Picture a book lying open before you, but this book has no words. Instead, it has layers, thin bands of color stacked one upon another, like the rings inside a tree trunk. Each layer tells a story about a moment in time. Each stripe holds the memory of seasons that passed thousands of years ago. This is how sedimentary rock speaks to us, in whispers of sand and clay. Beneath your feet right now, the Earth holds these layered stories. Every riverbank you have ever walked beside, every beach where you have watched waves roll in, every hillside where rain has carried soil downward. All of these places are writing new chapters in the great geological book. But the chapters we care about tonight were written long ago, when your ancestors first began their journeys across the world. Imagine standing beside an ancient river. The year is 40,000 years ago. You watch as spring floods carry new sediment downstream. The rushing water sorts this material like a careful librarian organizing books. Heavy particles settle first. Lighter ones drift further before finding their resting place. When the floodwaters recede, they leave behind a thin layer of sand and silt. This layer covers everything. The bones of animals that died during winter. The stone tools that someone dropped while crossing the river. The charcoal from fires that warmed families through cold nights. Then comes summer, with different rains and different sediment. A new layer forms on top of the first. Then autumn brings its own deposits. Winter adds another layer. Year after year, the stories stack up. Over thousands of years, the weight of all these layers presses down. The bottom layers compress and harden. They become sedimentary rock. But they never lose their stories. Each layer remains distinct, like pages in that wordless book, and sometimes, pressed between those pages like flowers in an old diary, archaeologists find the traces of human life, a spear point made from flint, a bead carved from bone, the foundation stones of a shelter, the remains of a cooking fire. These artifacts become part of the layer that was forming when people lived and worked in that place. This is how geologists create a calendar of human migration. They do not need written records, they read the layers instead. When they find the same type of stone tool in layers from different places, they know those tools were made during the same time period. When they trace these tools across a continent, they can follow the path that people took as they moved from place to place. The layers tell other stories too. They show when the climate changed. They record droughts that lasted for decades. They preserve the evidence of volcanic eruptions that turned day into night across vast regions. And in these climate Stories, we begin to understand why people moved when they did. Consider the layers that formed during the last ice age. In some places, they show thick deposits of wind-blown dust. This tells us that the land was cold and dry, with few plants to hold the soil in place. These would have been difficult places for people to live, but in other layers from the same time period, we find different stories. Rich dark soils that formed under grasslands. Evidence of rivers that supported fish and game. These layers show us where people could thrive, even during harsh times. The migration paths become clear when we read both stories together. People moved away from the barren lands recorded in dusty layers. They followed the river valleys preserved in rich, dark sediments. Sometimes the layers reveal sudden changes. A thick band of volcanic ash appears between two normal layers. This ash can be traced to a specific volcanic eruption. Scientists can determine exactly when that eruption occurred. This gives them a precise date for everything found above and below that ash layer. These volcanic time markers act like bookmarks in the geological story. They help scientists synchronize events from different places. An artifact found below the ash in one location and below the same ash in another location must have been left by people living at the same time. Layer by layer, the story of human expansion emerges. In the earliest layers, we find evidence of people only in Africa. Stone tools with distinctive shapes, hearths where families gathered around fires, the bones of animals they hunted. Then in slightly younger layers, similar tools appear in the Middle East. The same techniques for making fire, the same ways of preparing food. This tells us that people had begun to move out of Africa, carrying their knowledge and traditions with them. As we read upward through younger and younger layers, the evidence spreads. Tools appear in India, then in Southeast Asia. Different styles develop in different regions as people adapted to new environments. But the connections remain visible. A particular way of shaping stone spreads along river valleys. A new method for making fire appears simultaneously across vast distances. These patterns in the layers show us not just where people went, but how ideas traveled with them. The layered stories become more complex as time passes. Different groups develop their own traditions. They create new types of tools. They discover new ways to use the resources around them. All of this innovation gets preserved in the layers, creating a record of human creativity and adaptation. Some layers tell sad stories, evidence of settlements that were abandoned, tools left behind in haste. These layers often coincide with evidence of climate disasters, floods that destroyed entire valleys, droughts that lasted for generations, volcanic eruptions that made large regions uninhabitable. But the layers also show resilience. People survived these disasters. They found new places to live. They adapted their tools and techniques to new environments. They continued moving, continued exploring, continued growing in knowledge and numbers. Reading these layered stories requires patience. Geologists spend years carefully excavating single sites. They map each layer. They catalogue every artifact. They analyze soil chemistry to understand ancient climates. They use microscopes to identify pollen grains that tell them what plants grew in each time period. It is slow work, like translating a complex language one word at a time. But gradually, the story emerges. And what a story it is. The layers reveal a species that never stopped moving, never stopped exploring, never stopped adapting to new challenges and opportunities. Your own life is being added to these layers right now. Every step you take, every fire you light, every tool you use, all of this becomes part of the sedimentary record that future geologists might read. In the next chapter of our journey, we will discover how certain types of rock traveled much further than the people who first found them, creating trails across continents that we can follow even today. Hold a piece of obsidian in your mind tonight. Feel its smooth, cool surface. See how it catches light like a dark mirror. Notice how its edges can be sharper than any metal blade. This volcanic glass, born in the heart of fire, became one of humanity's most treasured materials. And it remembers. Every journey it has taken. When a volcano erupts, it sometimes creates obsidian. The lava flows out thick and heavy like dark honey. But when this molten rock meets air or water, it cools so quickly that crystals cannot form. Instead, it hardens into natural glass. Black glass, green glass. Sometimes glass with bands of color flowing through it like frozen smoke. Each piece of obsidian carries a secret signature, a chemical fingerprint that tells exactly which volcano created it. Scientists can read this signature like a birth certificate written in atoms. Imagine your ancestors discovering obsidian for the first time. They would have found it near volcanoes, scattered across the landscape like dark jewels. When they picked up these strange stones, they discovered something remarkable. Obsidian could be shaped into tools sharper than anything they had ever known. A skilled toolmaker could strike obsidian in just the right way. The glass would fracture in predictable patterns, creating edges only a few molecules thick. These edges were sharper than modern surgical scalpels. They could cut through hide and wood and bone with ease. But here is the mystery that obsidian holds. Archaeologists find obsidian tools hundreds of miles from the nearest volcano, sometimes thousands of miles away, in places where obsidian could never have formed naturally. This tells us something profound about our ancestors. They were not isolated groups living alone in the wilderness. They were connected. They traded with each other across vast distances. They shared knowledge and resources and stories. Every piece of obsidian found far from its volcanic source is proof of a journey. Someone walked those miles. Someone carried that precious glass across rivers and mountains and deserts. Someone valued it enough to transport it further than seems possible for people traveling on foot. Consider the obsidian found in ancient sites across Europe. Scientists can trace these tools back to volcanoes in Italy, in Turkey, in other distant places. This means that 30,000 years ago, people were traveling across the entire continent. They were following trade routes that connected communities separated by hundreds of miles. The chemical signatures tell even more detailed stories. Obsidian from a single volcano might appear in sites spread across vast regions, but it appears during the same time period. This suggests that people were not just making occasional long journeys. They were part of regular trading networks. Families would specialize in different crafts. Some became expert toolmakers, knowing exactly how to shape obsidian into perfect blades. Others became traders, learning the safest paths across dangerous terrain. Still others became guides, memorizing the locations of water sources and good camping spots along the way. These trading expeditions were probably seasonal events. Groups would meet at certain places during certain times of year. They would trade obsidian for other valuable materials, shells from distant oceans, amber from northern forests, high-quality flint from particular quarries. But obsidian was special. It was not just useful, it was beautiful. Many pieces show evidence of careful shaping, beyond what practical use required. Ancient craftspeople made obsidian mirrors. They created ceremonial blades with elaborate patterns. They crafted jewelry that caught and reflected light. This beauty mattered to our ancestors. It tells us that they valued more than just survival. They appreciated art. They cared about how things looked and felt. They were willing to travel great distances for materials that satisfied not just their practical needs, but their desire for beauty. The obsidian trade networks grew more complex over time. What started as simple exchanges between neighboring groups became elaborate systems spanning continents. Obsidian from the Mediterranean reached sites in northern Europe. Pacific Island obsidian traveled throughout Oceania. North American obsidian crossed the continent from coast to coast. These networks required trust between strangers. They required shared languages, or at least shared ways of communicating. They required agreements about value and fair exchange. They required knowledge of geography and seasons and the behavior of animals along the trade routes. In other words, the obsidian trade required civilization, not cities or writing or governments, but the cooperation and communication that make complex societies possible. Some obsidian traveled in small quantities, over enormous distances. A single tool might pass through many hands before reaching its final destination. Like a message in a bottle, it carried information about distant places and peoples. When archaeologists find these far-traveled pieces, they can reconstruct ancient communication networks. They can see how ideas and innovations spread along the same paths that carried obsidian. New techniques for making tools, new ways of preparing food, new stories and songs and spiritual beliefs. The obsidian trails map the circulation of human knowledge. Even more remarkably, some obsidian sources were used for thousands of years by many different cultures. Generation after generation returned to the same volcanic quarries. They followed the same paths their ancestors had walked. They maintained trading relationships that lasted longer than entire civilizations. This suggests something beautiful about human nature. Despite changes in language and culture and technology, people continued to honor the connections their ancestors had made. They preserved the knowledge of where the best obsidian could be found. They maintained the trading relationships that had enriched their communities for countless generations. Today, scientists use sophisticated instruments to read the chemical signatures in obsidian. They can identify not just which volcano created a particular piece, but sometimes which specific lava flow it came from. This precision allows them to trace trading patterns with incredible accuracy. They discover that obsidian moved along river valleys and mountain passes. It traveled with migrating herds and seasonal gatherings. It followed coastlines and crossed straits. Wherever humans could go, obsidian went with them. Each piece tells a story of human curiosity and determination. Someone saw beauty in volcanic glass. Someone learned to shape it with skill and patience. Someone carried it far from home. Someone valued it enough to trade precious resources for it. These stories of ancient commerce reveal something essential about our species. We are not just survivors. We are creators and traders and explorers. We build connections across vast distances. We share beauty and knowledge and resources. But obsidian holds an even deeper secret. Within its glassy structure, invisible forces were captured at the moment of cooling, forces that point like ancient compasses toward magnetic north as it existed long ago. Imagine you could see the invisible. Tonight, picture the Earth's magnetic field as streams of gentle light flowing from pole to pole. These luminous currents curve through space around our planet, creating a protective shell that shields us from the harsh winds of the solar system. This magnetic field touches everything, including you, including the rocks beneath your feet, and most remarkably, it remembers. Right now, as you rest quietly, tiny particles of iron in certain rocks around you are aligned with this magnetic field. They point toward magnetic north, like countless microscopic compass needles. And they will continue pointing in that direction for thousands of years, long after the magnetic field itself has shifted and changed. This is the Earth's magnetic memory, and within this memory lie the stories of human migration. When your ancestors built their first fires, they unknowingly created time capsules. The heat from those ancient flames changed the rocks around the hearth. Iron particles within the heated stone began to move and realign themselves. As the rocks cooled, these particles locked into place, frozen in the direction of magnetic north as it existed on that specific night, thousands of years ago. Every campfire became a compass preserved in stone. Consider what this means. When archaeologists find an ancient hearth, they are not just finding evidence that people once lived there. They are finding a magnetic record of exactly when those people lived. The iron particles in the heated rocks point toward where magnetic north was located during that specific time period. Scientists know how the Earth's magnetic field has wandered over time. Magnetic north moves in slow, predictable patterns. Sometimes it drifts closer to true north. Sometimes it wanders away. Occasionally, over very long periods, the entire magnetic field flips completely upside down. By matching the magnetic direction preserved in ancient hearthstones to this known timeline, researchers can determine the precise age of archaeological sites. They can create calendars of human habitation that span tens of thousands of years. But the magnetic memory reveals more than just dates. It shows directions, patterns, movements across landscapes. When people migrated, they carried fire with them. They stopped to make camps. They built hearths in new places. Each fire left its magnetic signature in the surrounding rocks. By mapping these magnetic records across a continent, scientists can trace the actual paths that ancient peoples followed. Think of it as following breadcrumbs made of invisible magnetic trails. The magnetic signatures reveal something remarkable about early human migration. People did not wander randomly across the landscape. They followed specific routes. River valleys where water was reliable, mountain passes where crossing was possible, coastlines where resources were abundant. These preferred pathways show up, again and again, in the magnetic record. Different groups, separated by hundreds or thousands of years, used the same travel corridors. The magnetic signatures mark these ancient highways like invisible road signs pointing toward the future. Some rocks hold magnetic memories that are even more specific. When people shaped tools from iron-rich stones, the process of striking and grinding heated the minerals just enough to reset their magnetic alignment. The direction these tool-making sites point toward magnetic north tells us exactly when different tool-making technologies first appeared in different regions. This is how scientists trace the spread of new tool-making techniques across continents. They found that certain innovative methods appeared first in one location, then showed up in the magnetic record of sites hundreds of miles away. The timing preserved in the magnetic alignment shows how long it took for new ideas to travel along ancient trade routes. The Earth's magnetic memory also preserves evidence of the climate conditions that influenced human migration. When the magnetic field was recorded in rocks, it captured not just direction, but intensity. Strong magnetic signatures indicate stable climate periods. Weak or chaotic signatures often correspond to times of climate change. By comparing magnetic records to archaeological evidence, researchers discovered that major human migrations often occurred during periods of magnetic and climate instability. People moved when their environments became unpredictable. They sought new homes when the old ones could no longer support them. The magnetic record shows that these climate-driven migrations followed predictable patterns. During ice ages, people moved toward warmer regions. During warm periods, they expanded into previously frozen territories. The magnetic breadcrumbs mark these movements with precise timing and direction. Some magnetic signatures reveal surprising details about ancient daily life. Pottery kilns left strong magnetic records because they operated at high temperatures for extended periods. The direction and intensity of these signatures tell us not just when people made ceramics, but how they organized their communities around shared resources like kilns. Metalworking sites have distinctive magnetic signatures too. The furnaces, used to smelt copper and iron, created intense heat that completely reset the magnetic alignment of nearby rocks. These signatures help researchers understand when and where people first began working with metals, and how this knowledge spread from community to community. Even more remarkably, some magnetic signatures preserve evidence of magnetic storms caused by solar activity. When the sun sent particularly strong bursts of energy toward Earth, it temporarily disrupted the magnetic field. These disruptions are recorded in rocks that were heated during those specific time periods. By finding archaeological sites with matching magnetic storm signatures, scientists can synchronize events from different parts of the world with incredible precision. They can determine that certain migrations, innovations, or cultural changes happened simultaneously across vast distances. The magnetic memory also reveals how people adapted to different magnetic conditions. In regions where magnetic north wandered significantly, ancient peoples developed sophisticated navigation techniques that did not rely solely on magnetic compasses. They learned to read star patterns, ocean currents, and wind directions. But in regions where magnetic north remained stable for long periods, people developed navigation traditions based on magnetic readings. They passed down knowledge about which rocks could be used as natural compasses. They created stories and songs that preserved information about magnetic directions. This knowledge helped them maintain their migration routes across generations. Even when individual groups had not traveled certain paths for decades, they retained the cultural memory of which direction to go. The magnetic signatures in their tools and hearthstones match the magnetic knowledge preserved in their traditions. Modern scientists use incredibly sensitive instruments to read these ancient magnetic records. They can detect magnetic signals thousands of times weaker than the Earth's current magnetic field. They can distinguish between magnetic signatures created just hours apart. This precision allows them to reconstruct human migration patterns with remarkable detail. They can trace individual family groups as they moved across continents. They can identify specific campsites where people stopped for just a few nights. They can follow trade routes that connected communities thousands of miles apart. The magnetic memory continues to record human activity today. Every fire you light leaves its own magnetic signature. Every metal tool you use while it is heated adds to the record. Future archaeologists will be able to read the magnetic story of your life in the rocks around your home. But there are other waters that remember human passage. Waters that carve the very valleys where our ancestors chose to make their homes, and trace their paths toward new horizons. Listen to the sound of flowing water in your mind. Gentle and constant, patient and persistent. This is the voice that called to your ancestors across thousands of years. Rivers spoke to them in a language they understood instinctively, the language of life itself. Water means survival. Water means abundance. Water means a path through unknown territory. Tonight, we follow these liquid highways that guided human migration across continents. We learn how rivers carved not just valleys into the landscape, but pathways into the future of our species. Picture a river as it existed 20,000 years ago. The water runs clearer than any river you have seen today. Fish leap in silver arcs above the surface. Game animals come to drink at dawn and dusk. Along the banks, rich soil supports grasses and trees that provide food, shelter, and materials. For tools, this river is more than a source of water. It is an entire ecosystem, a ribbon of life cutting through landscapes that might otherwise be too harsh or barren to support human communities. Your ancestors recognized this abundance. They followed rivers the way you might follow a road today. Rivers provided not just the necessities of life, but reliable routes through unknown territory. A river would always lead somewhere. It would always provide fresh water along the way. It would always support the plants and animals that people needed to survive. But rivers do more than flow. They rise and fall with the seasons. They flood and recede. They slowly change their courses over centuries and millennia. And in doing all of this, they create geological formations that preserve the story of human habitation along their banks. These formations are called river terraces. Imagine them as steps carved into the landscape. Each step represents an ancient riverbank, a level where the river once flowed, perhaps thousands of years ago. When a river cuts deeper into its valley, it leaves behind these terraced steps. The old floodplains become elevated benches of land stretching away from the current riverbank. These terraces are like pages in a geological book, each one representing a different chapter in the river's history. And preserved within these terraces are the traces of everyone who ever lived beside that ancient river. When archaeologists excavate river terraces, they find layers of human occupation. Stone tools buried in ancient gravels, hearthstones that once surrounded cooking fires, food remains that tell us what people ate and how they prepared their meals, sometimes even the post, holes that mark where people built their shelters. Each terrace tells the story of a different time period. The highest terraces are the oldest. They preserve evidence of the first people to discover and settle along that river. Lower terraces hold the remains of later occupations. The current floodplain contains the most recent archaeological sites. By studying terraces at different elevations, scientists can trace how human use of river valleys changed over time. They can see when new groups arrived. They can identify periods when settlements were abandoned, perhaps due to climate change or conflicts. They can track the development of new technologies and cultural practices. The gravels within river terraces hold particularly detailed stories. Rivers sort sediments by size and weight as they flow. Heavy materials settle out first. Lighter materials travel farther downstream before finding their resting places. This natural sorting process means that artifacts become part of specific gravel layers based on their weight and the strength of the river current when they were deposited. Stone tools might concentrate in one layer, pottery fragments in another, organic materials in still another. Geologists can read these gravel layers like a chronological record. They know that certain types of sediment are deposited during floods, other types accumulate during dry seasons. Still others form when rivers change course suddenly due to earthquakes or landslides. By understanding these patterns, researchers can determine not just when people lived along ancient rivers, but what environmental conditions they experienced. They can identify periods of drought that might have forced people to migrate. They can pinpoint floods that destroyed settlements and forced communities to relocate to higher ground. River terraces also preserve evidence of how people modified their environments. Ancient irrigation channels show up as linear depressions in terrace surfaces. Fish weirs appear as stone alignments in former stream channels. Agricultural fields leave traces in the form of buried plough marks and crop remains. These modifications reveal something important about the relationship between humans and rivers. People did not simply live beside rivers passively. They actively managed water resources. They diverted streams to water their crops. They built channels to drain swampy areas. They constructed fish traps to harvest aquatic resources more efficiently. This environmental management required detailed knowledge of river behavior. People learned to predict seasonal floods. They understood how to channel water without causing erosion. They knew which types of soil would hold water and which would drain quickly. This knowledge was passed down through generations. Children learned by watching their parents work with water and soil. They developed an intuitive understanding of hydrology that allowed them to thrive in river environments throughout their lives. The archaeological evidence shows that this knowledge was remarkably sophisticated. Ancient irrigation systems rival modern engineering in their efficiency and durability. Some channels built thousands of years ago are still carrying water today. Some fish weirs still trap fish using the same principles their designers understood long ago. Rivers also served as communication networks. People could travel upstream to reach headwater regions. They could follow rivers downstream to reach larger communities or coastal areas. They could use rivers to transport heavy materials like stone for tools or timber for construction. The terrace record shows evidence of this riverine travel. Similar artifact styles appear along entire river systems, suggesting regular communication between upstream and downstream communities. Exotic materials show up in terrace deposits hundreds of miles from their sources, indicating long-distance transport along river routes. Some rivers served as highways for major migrations. When climate conditions changed, entire populations might follow river valleys to reach more hospitable regions. The terrace record preserves evidence of these mass movements in the form of sudden changes in artifact styles or settlement patterns. Other rivers marked boundaries between different cultural groups. The terrace record on one side of a river might contain completely different artifact styles from the record on the other side. These patterns suggest that rivers sometimes divided territories rather than uniting them. But most often, rivers brought people together. They were meeting places where different groups could gather safely. They were neutral zones where trade and cultural exchange could occur. They were corridors along which ideas and innovations could spread rapidly across vast distances. The story preserved in river terraces reveals how deeply water has shaped human civilization. Our ancestors understood that following rivers meant following life itself. They built their communities, planned their migrations, and structured their societies around the reliable abundance that flowing water provided. Today, scientists continue to read the messages written in river terraces. They use sophisticated, dating techniques to determine exactly when different terraces formed. They analyze sediment chemistry to understand ancient climate conditions. They map artifact distributions to trace migration patterns and cultural connections. Yet beyond these flowing highways of migration, our ancestors also discovered that when water froze into vast sheets of ice, it opened entirely different pathways across the world. Picture ice as patient as stone. Imagine frozen water that moves like slow rivers, flowing across continents over thousands of years. This is the world of glaciers, ancient ice sheets that once covered vast portions of our planet, creating barriers and bridges for human migration in ways that seem almost magical. Tonight, we journey into the world of frozen time. 20,000 years ago, much of the northern world lay buried beneath ice. Sheets of frozen water stretched across Canada, northern Europe, and Siberia. Some places had ice piles more than a mile thick. This ice was so heavy that it actually pressed the land beneath it downward, changing the shape of continents. But this Ice Age world was not a dead, frozen wasteland. It was a dynamic landscape where ice advanced and retreated like breathing, where meltwater carved new valleys and filled ancient ones, where the very geography of the world shifted as ice grew and shrank with changing climate. And through this changing world, your ancestors found their way. Glaciers are more than frozen water. They are archives. As they form, they trap everything they encounter. Dust from distant volcanic eruptions, pollen from ancient forests, bubbles of prehistoric atmosphere, and sometimes the tools and traces left by early humans. When glaciers advance, they bulldoze across the landscape. They push rocks and soil ahead of them like massive plows. They bury everything in their path under tons of ice. But when glaciers retreat, they reveal what they have preserved. They act like time machines, bringing artifacts from the deep past back to the surface. This is how archaeologists have discovered some of the most remarkable evidence of early human migration. Tools that were frozen in time when glaciers advanced over ancient campsites. Organic materials that would have decayed long ago in warmer climates, but were preserved in ice for thousands of years. In the European Alps, melting glaciers have revealed a continuous record of human activity spanning 5,000 years. As the ice retreats, it exposes layers of artifacts from different time periods. Stone Age tools appear alongside medieval trade goods and modern equipment, all preserved, in the order they were buried by advancing ice. Each layer tells part of the story of how people adapted to changing ice conditions. During warm periods, they moved higher into the mountains, following game animals and seeking resources like crystals and metals. During cold periods, they retreated to lower elevations, waiting for the ice to recede again. But ice sheets did more than preserve artifacts. They created the very pathways that made human migration possible. During the last ice age, so much water was locked up in glaciers that sea levels dropped by more than 300 feet. This exposed vast areas of land that are underwater today. Continents that seemed separated by impossible distances were connected by dry land bridges. The most famous of these bridges connected Asia to North America. The Bering Land Bridge, as wide as two modern states, allowed people to walk from Siberia to Alaska. But this bridge was not a narrow pathway. It was a vast grassland that supported herds of mammoth, bison, and other animals that people hunted for survival. Archaeological evidence shows that people lived on this land bridge for thousands of years. They were not desperately rushing across a dangerous passage. They were thriving in a rich environment that provided everything they needed. Some families may have spent their entire lives on land that is now beneath the Bering Sea. As the ice began to melt, new migration corridors opened. The massive ice sheets covering North America split apart, creating ice-free valleys that stretched from Alaska to the southern plains. These corridors allowed people to spread throughout the Americas for the first time. Geologists can trace exactly when these corridors opened by studying the moraines left by retreating glaciers. Moraines are piles of rocks and debris that glaciers push ahead of them. When glaciers retreat, They leave these piles behind like geological breadcrumbs marking their former positions. By dating the organic materials trapped in moraines, scientists can determine precisely when different migration routes became available. They can see that some corridors opened thousands of years before others. They can trace which paths people used first, and how long it took for human populations to spread through newly accessible territories. The ice also preserved evidence of the environmental conditions that early migrants encountered. Pollen grains, trapped in glacial ice, tell us what plants grew in different regions during different time periods. Ancient DNA extracted from ice cores reveals which animals lived where and when they appeared or disappeared from different areas. This information helps us understand not just where people could go, but why they chose particular routes. They followed corridors that supported the animals they hunted. They avoided areas where resources were scarce. They timed their movements to coincide with favorable weather and abundant food sources. Some of the most dramatic evidence comes from places where glacial lakes formed as ice dams melted. These lakes could be hundreds of miles long and incredibly deep. When the ice dams finally broke, the lakes drained catastrophically, carving enormous valleys in just a few days or weeks. These flood events created new landscapes almost instantly. River systems changed course. New valleys appeared where none existed before. Entire ecosystems were destroyed and reformed. People living in these regions had to adapt quickly to completely transformed environments. The geological evidence shows that human populations were remarkably resilient during these dramatic changes. Instead of being overwhelmed by glacial floods and landscape transformations, they learned to predict and prepare for them. They developed technologies and strategies that allowed them to thrive in rapidly changing environments. Ice-preserved artifacts show evidence of sophisticated cold-weather technologies. Bone needles for sewing warm clothing, snowshoes for traveling across frozen ground, ice fishing equipment for harvesting food from frozen lakes and rivers. These innovations allowed people to not just survive in glacial environments, but to actively explore and settle them. The story told by glacial geology reveals something remarkable about human adaptability. Our ancestors did not simply endure the Ice Age. They used it. They turned glacial barriers into migration highways. They transformed frozen wastelands into productive hunting grounds. They made homes in landscapes that were constantly changing. Modern climate change is causing glaciers around the world to retreat at unprecedented rates. As they melt, they are revealing archaeological treasures that have been frozen for thousands of years. Each artifact that emerges from the ice adds new details to our understanding of how people lived and moved during the Ice Age. But these glacial archives are also disappearing. Once exposed to modern temperatures, organic materials that survived for millennia in ice decay rapidly, scientists are racing to study and preserve these discoveries before they are lost forever. The Ice Age world may seem alien to us today, but the people who lived in it were not so different from you. They faced the same basic challenges of finding food, shelter, and safety. They formed families and communities. They developed technologies and cultural traditions. What makes their story remarkable is not just that they survived in such a harsh environment, but that they used the opportunities it provided to spread across the entire world. The same ice that seems so forbidding created the pathways that allowed human civilization to take root on every continent. As these ancient ice sheets finally release their secrets, they reveal landscapes beneath the waves that tell even older stories of human coastal wandering. Imagine walking along a beach that exists only in memory now. A shoreline that once stretched for hundreds of miles, where families gathered shells and fishermen launched their boats into calm waters. This beach lies beneath the ocean today, covered by waves that have risen and fallen with the planet's ancient rhythms. Tonight, we dive beneath the surface to explore the drowned worlds that hold the secrets of coastal migration. The ocean breathes slowly. Over thousands of years, sea levels rise and fall like the chest of a sleeping giant. During ice ages, water becomes locked in glaciers, and the sea drops to reveal vast coastal plains. When ice melts, water returns to fill the ocean basins, drowning the lands where people once lived. This breathing has happened many times in Earth's history. Each cycle has hidden and revealed different worlds. Each breath has preserved and destroyed evidence of human habitation along ancient shores. Your ancestors were drawn to coastlines like moths to flame. Coasts provided abundant resources. Fish swam in offshore waters. Shellfish clung to rocky shores. Seabirds nested on cliffs and beaches. Salt marshes supported waterfowl and marine plants. Rivers carried fresh water to the sea, creating estuaries rich with life. But coasts offered more than food. They provided highways for long-distance travel. People could follow shorelines for thousands of miles, using familiar landmarks and predictable resources. They could launch boats to cross straits and reach distant islands. They could establish trading networks that spanned entire ocean basins. The archaeological evidence of these coastal civilizations now lies underwater. Drowned by rising seas, it waits beneath the waves like a vast library written in stone and shell. Marine archaeologists use sophisticated sonar equipment to map the seafloor. They create detailed images of underwater landscapes that reveal the drowned coastlines of the past. These maps show ancient river valleys that once carried fresh water to the sea. They reveal coastal plains that once supported vast settlements. They outline islands that are now submerged seamounts. Some of the most remarkable discoveries lie off the coast of Southeast Asia. Here, falling sea levels during the last ice age exposed a land bridge connecting the mainland to what are now islands. This ancient continent, called Sunderland, was larger than modern India. Rivers flowed across its surface. Lakes dotted its interior. Forests covered its hills and plains. People lived throughout Sunderland for tens of thousands of years. They built settlements along its rivers and coasts. They developed sophisticated boat-building techniques that allowed them to reach islands that remained separated by water, even during the lowest sea levels. They created trade networks that connected communities across hundreds of miles of territory. When the ice began to melt and sea levels started rising, these coastal communities faced a crisis. The rising water threatened their homes, their fields, and their sacred places. But instead of abandoning their coastal lifestyle, they adapted. They became some of the world's first true maritime peoples. They developed boats capable of long ocean voyages. They learned to navigate by stars and ocean currents. They created floating settlements that could move with changing conditions. They established trading posts on islands and maintained connections across growing expanses of water. The evidence of this maritime adaptation is preserved in underwater archaeological sites throughout Southeast Asia. Stone tools adapted for processing marine resources. Pottery designed for storing fresh water on long voyages. Fishhooks carved from bone and shell. Harbour installations built to accommodate rising sea levels. Similar stories unfold along other drowned coastlines around the world. Off the coast of Europe, underwater surveys have revealed evidence of coastal settlements that thrived during the last ice age. Stone circles that may have been astronomical observatories. Shell middens that record thousands of years of seafood. Harvesting. Harbour works that show sophisticated understanding of tides and currents. The North Sea, which now separates Britain from continental Europe, was once a vast coastal plain called Doggerland. This lost land supported herds of mammoth and other large animals. Rivers meandered across its surface. Forests provided timber and other resources. And throughout this landscape, people lived and thrived. As sea levels rose, Doggerland gradually disappeared beneath the waves. But the archaeological evidence suggests that this was not a sudden catastrophe. People had time to adapt. They moved their settlements to higher ground. They developed new technologies for living in increasingly marshy environments. They maintained their communities even as their homelands slowly vanished. Fishing boats in the North Sea sometimes bring up artifacts from this drowned world. Stone Age tools tangled in their nets, bones of extinct animals, fragments of ancient trees. Each discovery adds details to our understanding of how people lived in Doggerland and how they coped with its gradual submersion. the geological evidence, preserved in underwater sediments, tells an even more detailed story. Core samples taken from the seafloor contain layers of peat that formed in ancient marshes. These layers hold pollen grains that reveal what plants grew in different areas during different time periods. They contain microscopic fossils that show how marine and freshwater environments changed as sea levels rose. By studying these sediment cores, scientists can reconstruct the exact timing and pace of sea level rise in different regions. They can see that the drowning of coastal areas was not uniform. Some regions flooded rapidly when ice dams broke and released vast quantities of meltwater. Others were submerged gradually over many centuries. This variable timing helps explain different patterns of human adaptation. In areas where flooding was gradual, people had time to develop new technologies and social structures. They could plan migrations to higher ground. They could maintain cultural continuity even as their physical environment changed. In areas where flooding was rapid, the archaeological record shows more dramatic cultural disruptions, sudden abandonment of settlements, rapid adoption of new technologies, evidence of population movements over long distances in short time periods. But in both cases, people survived. They adapted. They found new ways to thrive in changing environments. The underwater archaeological record preserves evidence of remarkable human resilience and creativity in the face of environmental challenges. Modern climate change is causing sea levels to rise again. Coastal communities around the world face challenges similar to those their ancestors confronted thousands of years ago. The archaeological evidence from drowned coastlines provides insights into how people have successfully adapted to rising seas in the past. It shows that coastal peoples have always been innovators. They developed new technologies for living with water. They created social networks that could function across maritime environments. They maintained cultural traditions, even as their physical world changed around them. The study of drowned coastlines also reveals something profound about human relationships with the sea. For our ancestors, the ocean was not a barrier. It was a highway. Not a source of danger, but a provider of resources. Not an alien environment, but an extension of their familiar world. This maritime heritage lives on in coastal communities today, fishing villages that maintain traditions thousands of years old. Navigation techniques passed down through countless generations. Cultural practices that reflect deep understanding of ocean rhythms and marine ecosystems. The drowned coastlines preserve more than just archaeological artifacts. They preserve evidence of humanity's long partnership with the sea. They show us a world where people lived in harmony with rising and falling waters, where communities thrived on the boundary between land and ocean. As we explore these underwater worlds, we discover not just where our ancestors lived, but how they thought, how they saw the relationship between humans and nature, how they adapted to environmental change while maintaining their cultural identity. But beneath the waves and above ground alike, there are places where time seems to stand still completely, where darkness preserves the most intimate details of ancient human life. Step into absolute darkness. Feel the cool, still air that has remained unchanged for thousands of years. Listen to the silence that swallows every sound. This is the world inside caves, where time stops and memory becomes stone. Tonight, we enter these underground sanctuaries, where your ancestors sought shelter and left their stories written in bone and ash. Caves exist in a realm beyond seasons. While outside temperatures rise and fall, storms rage and pass, civilizations rise and crumble, cave interiors remain constant, cool and dark and protected. This stability makes them perfect preservers of the past. When your ancestors entered caves, they stepped into natural time capsules. Everything they brought with them, everything they left behind, became part of an environment that would preserve it for millennia. Food scraps that would decay in days outdoors lasted for thousands of years in cave darkness. Footprints pressed into cave mud hardened into permanent records. Ashes from fires became layers in the geological story of human habitation. Picture a family group 30,000 years ago seeking shelter from a harsh winter storm. They find a cave entrance, a dark mouth in a limestone cliff. Inside, the temperature is perfect. Not warm, but not freezing. The air is still and dry. Fresh water drips from stalactites into pools on the cave floor. This cave becomes their winter home. They build fires near the entrance, where smoke can escape. They prepare animal hides for clothing and bedding. They create tools from bone and stone. They paint images on the cave walls, telling stories of their hunts and their dreams. Each activity leaves traces. The carbon from their fires darkens specific layers of sediment. The bones from their meals accumulate in refuse piles. Their tools drop into crevices, where they will remain undisturbed. Their footprints press into soft cave sediments that slowly harden into rock-like deposits. Over time, these traces become buried under new layers of sediment, dust blown in from outside, sand carried by underground streams, calcite deposited by dripping water. Layer by layer, the evidence of human occupation becomes sealed away like pages in a stone book. Centuries pass. The climate changes. Different. People find the same cave. They too leave their traces. Their artifacts mix with older ones, creating a chronological record of who used the cave and when. Each group adds its own chapter to the story written in cave sediments. The cave itself participates in this record-keeping. Water seeping through limestone rock dissolves minerals and redeposits them as flowstone formations. These formations grow incredibly slowly, sometimes less than a millimeter per year, but they preserve precise records of environmental conditions outside the cave. When climate is stable, flowstone formations grow in smooth, even layers. During periods of environmental stress, the formations record changes in water chemistry and temperature. Drought years appear as thin layers. Wet years create thicker deposits. Volcanic eruptions show up as layers with unusual mineral compositions. Scientists can read these flowstone records like tree rings, determining exactly when different environmental conditions occurred. When they find human artifacts sealed beneath specific flowstone layers, they know precisely how old those artifacts are and what environmental conditions the people who made them experienced. Cave sediments preserve even more detailed information. Pollen grains carried into caves by wind and water tell us what plants grew outside during different time periods. Insect remains reveal seasonal patterns and climate conditions. Microscopic fossils show how local ecosystems changed over time. This environmental data helps explain patterns in human cave use. During harsh climate periods, caves show evidence of intensive occupation. People used them as long-term shelters, building elaborate hearths and storage areas. During mild periods, the same caves might show only brief visits, suggesting people used them as temporary camps during travels. Some caves preserve evidence of specialized activities. Workshop areas where people made tools. Storage chambers where they kept supplies for future use. Ceremonial spaces where they created art or conducted rituals. Burial areas where they laid their dead to rest. The famous painted caves of Europe show us that our ancestors used these underground spaces for more than just shelter. They created some of humanity's earliest art in cave chambers deep beneath the earth. They mixed pigments from minerals and applied them to cave walls by torchlight, creating images that have survived for 40,000 years. These cave paintings often appear in the most remote, difficult-to-reach chambers. This suggests they held special meaning. Perhaps they were sacred spaces where people came to commune with the spirits of the animals they hunted. Perhaps they were teaching spaces where knowledge was passed from one generation to the next. The pigments used in cave paintings provide additional clues about human migration and trade. Some colors come from minerals that had to be transported long distances. Red ochre from specific geological formations. Black manganese from distant sources. The presence of these exotic pigments in cave paintings shows that people maintained far-reaching trade networks even tens of thousands of years ago. Cave preserves also hold some of the most important evidence of early human evolution and migration. Bones of early human species preserved in perfect condition by cave environments. These remains show how humans evolved and adapted as they spread across different continents and climates. DNA extracted from cave sediments provides even more detailed information. Even when bones have long since dissolved away, tiny fragments of ancient DNA persist in cave soils. Scientists can extract this genetic material and use it to identify which human species lived in a cave and when. This genetic evidence has revealed surprising details about human migration patterns. Some caves contain DNA from multiple human species who lived there at different times. Others show evidence of interbreeding between different human groups. Still others preserve genetic signatures that help scientists trace the origins and movements of entire populations. Cave formations also record the impact humans had on their environments. Changes in sediment composition show when people first began using fire regularly. Increased bone accumulations mark the development of more sophisticated hunting techniques. Chemical changes in flowstone formations may reflect human impacts on local water systems. Modern cave exploration continues to reveal new chapters in the human story. Remote cave systems in unexplored regions sometimes contain archaeological treasures that have remained untouched for thousands of years. Underwater caves preserve evidence from times when sea levels were much lower. High-altitude caves hold artifacts from peoples who learned to live in the most challenging mountain environments. Each new cave discovery adds details to our understanding of how humans adapted to different environments during their migrations around the world. They show us a species that was not just surviving, but creating beauty, developing technology, and building communities even in the most challenging conditions. The darkness that seemed so forbidding to our ancestors became the very thing that preserved their stories for us to discover thousands of years later. Yet beyond these shelters in stone, our ancestors left traces in places where they cooked and gathered, where the very chemistry of soil still whispers their presence across the millennia. Picture the first spark struck by human hands. See it catch in dry tinder, grow into flame, then settle into steady coals that will warm bodies and cook food through a long night. This fire, burning perhaps 50,000 years ago, leaves more than light and heat. It writes its story in the chemistry of the earth beneath it. Tonight, we learn to read the invisible signatures that fire leaves in soil, signatures that reveal the most intimate details of how our ancestors lived. Fire transforms everything. The obvious changes are easy to see. Wood becomes ash. Raw meat becomes cooked food. Cold becomes warmth. But fire also creates changes invisible to the naked eye, changes written in the atomic structure of soil and stone. When fire burns in the same place repeatedly, it alters the very chemistry of the ground. Heat drives moisture from the soil. Organic compounds break down into simpler molecules. Minerals change their crystalline structure. Magnetic particles realign themselves. The pH of the soil shifts as ash dissolves into the surrounding earth. Each type of change leaves its own chemical signature, a fingerprint that scientists can detect thousands of years later using sophisticated laboratory equipment. Consider a typical hearth from 20,000 years ago. Your ancestors choose a sheltered spot near a stream. They arrange stones in a circle to contain their fire. They gather wood from the surrounding forest. They settle in for several days of cooking, tool-making, and socializing around the flames. Each night, the fire burns a little deeper into the soil. Each day, they add new fuel and new food to cook. Grease from roasted meat soaks into the ground. Plant juices from cooked roots leave their chemical traces. Wood ash mixes with earth to create a distinctive alkaline layer. When they finally move on, continuing their seasonal migration, the hearth site looks empty. Wind scatters the remaining ashes. Rain washes away the visible traces. Plants grow back to cover the disturbed ground. Within a few years, no sign remains that people ever camped there. But the chemistry remembers everything. Modern scientists can take soil samples from that ancient campsite and analyze them atom by atom. They find elevated levels of phosphorus from bones that were burned in the fire. They detect nitrogen compounds from decomposed organic matter. They identify specific fatty acids that came from cooking different types of meat and plants. These chemical signatures are so precise that researchers can determine not just that people made fires at a particular location, but what they cooked in those fires. Fish bones leave different chemical traces than mammoth bones. Plant roots create different signatures than tree nuts. Even the type of wood used for fuel leaves its own distinctive chemical fingerprint. This level of detail allows scientists to reconstruct the daily lives of ancient peoples with remarkable accuracy. They can see seasonal patterns in diet as people moved between different environments. They can identify periods of abundance when many different foods were available. They can detect times of scarcity when people had fewer choices. The chemical analysis also reveals information about the environment that surrounded ancient campsites. Soil chemistry reflects the types of plants that grew nearby. The presence of certain minerals indicates the geological formations from which people gathered their raw materials. Traces of salt suggest proximity to oceans or salt deposits. By mapping the chemical signatures of hearth sites across large regions, researchers can trace migration routes with precision impossible through artifacts alone. They can see where people stopped frequently and where they traveled quickly. They can identify seasonal camps used year after year and temporary stops made during longer journeys. Some of the most remarkable discoveries come from hearth sites where people experimented with new technologies. The chemical signatures reveal the first attempts at metalworking, thousands of years before metal artifacts appear in the archaeological record. They show evidence of early pottery making, recorded in the clay particles that remain in soil long after the pots themselves have crumbled away. Fire-altered soils also preserve evidence of the social organization around ancient hearths. Large hearths with complex chemical signatures suggest communal cooking areas where extended families gathered. Small, simple hearths indicate individual family units. The spacing and arrangement of multiple hearth sites reveals how communities organize their living spaces. The chemistry of cooking fires tells stories about human ingenuity and adaptation. Chemical traces show that people learned to use different types of wood to achieve specific cooking temperatures. They discovered how to combine certain plants to create more nutritious meals. They developed techniques for preserving food using smoke and controlled heat. Some hearth sites contain chemical evidence of medicinal plant use. Compounds found in healing plants appear in the ash layers, suggesting that people were preparing herbal remedies around their fires. Other sites show evidence of plants used for tools and clothing, indicating that hearths served as workshops as well as kitchens. The geological context of hearth sites provides additional clues about why people chose specific locations for their camps. Chemical analysis of surrounding soils reveals the resources that drew people to particular places. High-quality flint for toolmaking, clay suitable for pottery, ochre for pigments and decoration. These resource-based settlement patterns help explain the movement of ideas and technologies across ancient landscapes. People didn't just follow game animals or water sources, they also followed geological resources, creating trade networks and cultural connections based on shared needs for specific types of stone and mineral. Fire chemistry also preserves evidence of environmental changes that influenced human migration. During periods of climate stress, hearth sites show chemical signatures indicating that people burned whatever fuel they could find, including plants that would normally be too green or too poor in quality. During stable periods, the chemistry suggests selective use of preferred fuel types. Some hearth sites contain evidence of catastrophic events that force people to abandon their camps suddenly. Chemical layers show evidence of volcanic ashfalls, flood deposits, or other natural disasters. The abrupt changes in soil chemistry mark moments when communities had to adapt quickly to dramatically changed environments. The study of ancient hearth chemistry has also revealed surprising information about early human cooperation and conflict. Sites where different cultural groups met and interacted show mixed chemical signatures, suggesting shared meals and cultural exchange. Other sites show evidence of rapid abandonment and burning, possibly indicating conflicts or raids. Modern analytical techniques continue to reveal new details from ancient hearth sites. DNA analysis of soil samples can identify the specific species of animals that were cooked in ancient fires. Isotope analysis reveals the geographic origins of food and fuel, showing how far people traveled to gather resources. Advanced chemical techniques can even detect traces of wooden tools and baskets that were used around ancient fires. These organic materials decay completely in most environments, but they sometimes leave molecular signatures in soil that persist for thousands of years. The chemical record of ancient hearths creates an intimate connection between modern scientists and ancient peoples. Every molecule analyzed is a direct link to someone who lived and cooked and gathered around fires thousands of years ago. Each chemical signature preserves a moment of daily life from the deep past. This molecular archaeology reveals that fire was much more than a tool for early humans. It was the center of social life, the heart of technology, and the foundation of culture. The chemistry of ancient hearths shows us people who were not just surviving, but creating rich, complex communities around their fires. As we trace these chemical signatures across landscapes and through time, we begin to see patterns that connect individual hearth sites to larger geological processes that shape the very ground beneath our ancestors' feet. Feel the solid ground beneath you. It seems so permanent, so unchanging. But deep below, the earth moves constantly. Vast plates of rock drift like slow ships across the planet's surface. Where these plates meet and grind against each other, they create cracks in the world. Fault lines that release the planet's restless energy in earthquakes and volcanic eruptions. Tonight, we explore how this geological restlessness shaped the paths of human migration. The Earth's fault lines are not random scars across the landscape. They follow patterns older than life itself. Mountain ranges rise where plates collide. Ocean basins form where they pull apart. Rivers often follow fault lines because water finds the weakest paths through rock. Valleys form along these lines of geological weakness. Your ancestors learned to read these geological patterns, not through scientific instruments, but through careful observation passed down through generations. They noticed which areas shook frequently. They observed which valleys provided the safest passage through mountainous terrain. They learned which regions offered stable ground for long-term settlements. This knowledge became part of their cultural wisdom. Stories and songs that preserved information about safe and dangerous places. Migration routes that avoided areas prone to landslides and earthquakes. Settlement patterns that took advantage of geological stability. The archaeological record shows how deeply earthquake activity influenced human migration patterns. In seismically active regions, settlements tend to be temporary and small. People built with materials that could be quickly abandoned. They created social networks that could provide support after natural disasters. They developed technologies for predicting and surviving geological upheavals. Consider the great fault systems that cross continents. The San Andreas Fault in California, the Great Rift Valley in Africa, the Anatolian Fault in Turkey. Each of these geological features created both barriers and corridors for human movement. Along some fault lines, frequent earthquakes created landscape conditions that were actually beneficial for early humans. Fault activity brings deep minerals to the surface. It creates springs where groundwater emerges along fracture lines. It generates diverse topography that supports different types of plant and animal communities. The Great Rift Valley in Africa provides a remarkable example of how geological activity influenced human evolution and migration. This massive fault system stretches for thousands of miles across eastern Africa. Its formation created the diverse landscapes where early humans first evolved. The Rift Valley provided protected corridors for north-south movement. Its fault-generated springs supplied reliable water sources. Its volcanic activity created fertile soils that supported abundant plant life. Its varied elevations created different climate zones where early humans could find resources year-round. Archaeological sites along the Rift Valley preserve evidence of human occupations spanning millions of years. The same geological processes that created favorable conditions for early human evolution also preserved the fossil evidence of that evolution in volcanic ash layers and sedimentary deposits. As humans spread beyond Africa, they continued to follow geological corridors, mountain passes created by fault activity, river valleys carved along geological weak zones, coastlines shaped by tectonic uplift and subsidence. The Mediterranean region shows how complex geological activity influenced human migration routes. This area sits at the intersection of multiple tectonic plates. The resulting earthquake activity created a patchwork of islands, peninsulas, and mountain ranges that required sophisticated navigation skills to traverse. Archaeological evidence shows that people living in this seismically active region developed remarkable resilience strategies. They built flexible settlements that could be quickly rebuilt after earthquakes. They maintained multiple resource bases so that destruction in one area would not threaten their survival. They created extensive trade networks that provided support during recovery from natural disasters. Some of the most dramatic examples of geological influence on human migration come from volcanic eruptions associated with fault activity. Major eruptions could make entire regions uninhabitable for years or decades. The geological record preserves evidence of these catastrophic events in ash layers that can be traced across continents. When Mount Toba erupted in Indonesia 74,000 years ago, it created one of the largest volcanic events in human history. The ash from this eruption has been found in archaeological sites across Asia and Africa. The climatic effects of this eruption may have influenced human migration patterns across the entire Old World. But people did not simply flee from geological activity, they also learned to use it. Volcanic regions provided obsidian for toolmaking, fault-generated hot springs offered warm water for cooking and cleaning. Mineral deposits brought to the surface by tectonic activity supplied raw materials for pigments and decorations. The timing of geological events also influenced human migration patterns. Archaeological evidence suggests that some major population movements coincided with periods of increased seismic activity. Whether people were fleeing unstable regions or taking advantage of newly opened geological corridors, the Earth's restlessness clearly played a role in shaping human dispersal patterns. Geological instability may have actually accelerated human technological and cultural development. Communities that faced regular natural disasters needed to develop more sophisticated tools and social organization. They had to become more adaptable and innovative to survive in unpredictable environments. The archaeological record shows that many important technological innovations first appeared in seismically active regions. Advanced building techniques that could withstand earthquakes, portable technologies that could be quickly transported during evacuations, food storage and preservation methods that could sustain communities through disaster recovery periods. Modern geological research continues to reveal new connections between fault activity and ancient human settlement patterns. Paleoseismology, the study of prehistoric earthquakes, uses geological evidence to reconstruct the timing and magnitude of ancient seismic events. By comparing this geological timeline with archaeological evidence, researchers can see how human communities responded to specific earthquakes and volcanic eruptions. They can identify periods when geological disasters forced large-scale migrations. They can trace how recovery from natural disasters influenced cultural development and technological innovation. Some fault systems preserve remarkably detailed records of human adaptation to geological hazards. Along the Dead Sea Rift, for example, geological layers contain evidence of earthquakes that occurred at specific moments in human history. Archaeological sites in the same area show how communities adjusted their settlement patterns and building techniques in response to seismic activity. The study of ancient fault activity also helps modern communities understand their own geological risks. Areas that experienced frequent earthquakes in the past are likely to experience them again in the future. Archaeological evidence of how ancient peoples successfully adapted to these risks can inform modern disaster preparedness strategies. But geological instability was not always a threat to early human communities. In some cases, fault activity created exactly the conditions that allowed human societies to flourish. The geological diversity generated by tectonic activity provided the varied resources that supported complex communities and long-distance trade networks. The fault lines that seemed to create barriers often became corridors. The geological instability that appeared threatening often provided opportunities. Our ancestors learned to read the Earth's restless moods and use them to their advantage. This deep relationship between human migration and geological activity continues today. Modern populations still concentrate along fault lines that provide water, minerals, and transportation corridors. We still face the challenge of adapting to the Earth's restless energy. As we trace these ancient paths along fault lines and through geological corridors, we discover that our ancestors navigated not just a physical landscape, but also learned to thrive in places where water itself became the scarcest and most precious guide across vast emptiness. Imagine vast emptiness stretching beyond every horizon. Sand dunes that shift with each wind. Rock formations baked under relentless sun. This is how we think of deserts today. Harsh, barren, impossible to cross without modern technology. But your ancestors saw something different when they looked across these arid landscapes. They saw highways written in stone. Tonight, we learn how geological knowledge turned the world's most challenging environments into corridors for human migration. Deserts are not empty. They are libraries of preservation. In forests, fallen leaves decay within seasons. Rain dissolves artifacts. Living roots disturb archaeological layers. But in deserts, things last. The dry air mummifies organic materials. The stable temperatures prevent cycles of expansion and contraction that destroy delicate remains. The sparse vegetation leaves archaeological sites undisturbed for thousands of years. Wind becomes the desert's librarian. It sorts and arranges sediments with precision that no human filing system could match. Heavy particles stay in place during gentle breezes. Light materials travel farther during strong winds. Each storm rearranges the landscape according to weight and density, creating layers that preserve the story of everything that has ever crossed the desert. Your ancestors learned to read these wind-written records. They understood that certain types of sediment accumulate near water sources. They recognized the geological formations that indicate underground springs. They knew how to follow the subtle mineral traces that lead from surface rocks to hidden aquifers deep below. Water shapes deserts more than we realize. Though rain may fall only occasionally, when it comes, it transforms the landscape dramatically. Flash floods carve deep arroyos through seemingly solid rock. Temporary lakes form in low-lying areas, then evaporate to leave behind mineral deposits that mark their locations for centuries. These ephemeral water features created the stepping stones that allowed human migration across desert regions. A spring that flows for just a few weeks each year can sustain life during the crucial period when travelers need to cross vast, arid expanses. An oasis that appears only during certain seasons can support entire communities during the times when they need it most. Geological knowledge made the difference between life and death in these environments. People learned to recognize the subtle signs that indicate underground water. Certain types of vegetation that grow only where their roots can reach groundwater. Rock formations that create natural collection points for rare rainfall. Mineral stains on canyon walls that mark the seasonal flow of hidden streams. The Sahara Desert preserves remarkable evidence of how humans adapted to increasingly arid conditions. 10,000 years ago, this region was much wetter than today. Rivers flowed where only dry valleys exist now. Lakes supported fishing communities in areas that are now pure sand. Rock art from this period shows people hunting hippos and crocodiles in what is now one of the world's most extreme deserts. As the climate gradually dried, people did not simply abandon the region. They adapted. They learned to follow underground water sources. They developed technologies for storing and transporting water across long distances. They created social networks that allowed them to share information about distant water sources and seasonal changes in resource availability. The geological record shows how this adaptation process worked. Archaeological sites from the early wet period cluster around ancient lake shores and river channels. As conditions became drier, site locations shift to follow retreating water sources. The most recent sites concentrate at deep water holes and reliable springs that continue flowing even under extreme drought conditions. This gradual adaptation created some of humanity's most sophisticated desert survival technologies. Archaeological sites preserve evidence of underground water storage systems, rock-lined channels that collected and concentrated rare rainfall, sophisticated astronomical knowledge used to predict seasonal changes in weather patterns. Desert peoples also became masters of geological prospecting. They learned to trace valuable minerals back to their sources across hundreds of miles of difficult terrain. They developed trade networks that carried goods across seemingly impossible distances. They created wayfinding systems based on subtle geological landmarks that allowed precise navigation across featureless landscapes. The preservation conditions in deserts have revealed details about these ancient technologies that would be lost in other environments. Organic materials like rope and wood survive for thousands of years. Footprint trails pressed into mud during rare wet periods harden into permanent records. Even the remains of temporary shelters built from perishable materials can be reconstructed from the traces they leave in wind-blown sediments. Some of the most remarkable discoveries come from ancient lake beds that are now completely dry. These paleolakes preserve layered sediments that record thousands of years of environmental change. Within these layers, archaeologists find evidence of human adaptation to gradually changing conditions. The sediment layers show periods when lakes shrank and people concentrated around shrinking shorelines. Other layers record times when increased rainfall temporarily expanded water resources and allowed populations to spread into previously uninhabitable areas. Still, other layers preserve evidence of drought periods so severe that even the most reliable springs failed and entire regions had to be abandoned. But people always returned when conditions improved. The geological record shows cycles of abandonment and reoccupation that span thousands of years. Each time people returned to familiar areas, they brought new knowledge and technologies developed during their time in other regions. This cyclical pattern of desert occupation created cultural connections across vast distances. Ideas and innovations, developed during wet periods in one region, would spread to distant areas during subsequent dry periods when people were forced to migrate. Technologies perfected in extreme desert conditions would be carried back to more favorable areas when climate conditions improved. Desert preservation has also revealed evidence of the spiritual and artistic responses to these challenging environments. Rock art sites in desert regions contain some of humanity's oldest and most sophisticated astronomical observations. Petroglyphs record star patterns and celestial events that were crucial for navigation and seasonal prediction. The geological contexts of these art sites show that they were often located at important water sources or navigation landmarks. They served as information centers where travelers could find both physical refreshment and crucial knowledge about routes, resources, and seasonal patterns. Modern geological research continues to reveal new details about ancient desert adaptations. Satellite imagery can detect buried river channels and ancient oasis sites that are invisible from ground level. Chemical analysis of sediment cores from dry lakes reveals precise records of past climate changes that influenced human settlement patterns. Ground-penetrating radar can locate underground water sources that ancient peoples once used. Isotope analysis of archaeological remains can determine the geographic origins of people and materials, revealing the extent of ancient trade networks across desert regions. The story preserved in desert geology reveals human resourcefulness and adaptability at its finest. Your ancestors did not conquer these harsh environments through force or technology alone. They succeeded through careful observation, accumulated wisdom, and deep understanding of geological processes. They learned to work with the desert rather than against it. They used its preserving power to maintain landmarks and resource indicators across generations. They adapted their social structures to the patterns of resource availability that geology created. As our journey through deep time approaches its end, we recognize that the same forces of preservation and change continue to write their stories in the rocks beneath our feet. Rest quietly now and feel your connection to this ancient story. You are not separate from the geological record we have explored tonight. You are part of it. Every breath you take, every step you make, every place you call home becomes part of the ongoing narrative that the Earth writes in stone. Tonight, as our journey ends, we recognize that the migration story continues with you. The same geological processes that preserved evidence of your ancestors' movements are recording your life today. The concrete beneath your home will become sedimentary rock in some distant future. The metals in your tools will leave their chemical signatures in soil layers. The fires you light, whether in fireplaces or engines, alter the chemistry of the air and ground around you. Future geologists, perhaps thousands of years from now, will read these traces of your existence. They will decipher the story of how humans in the 21st century lived and moved across the planet. They will study the materials you used, the energy you consumed, the changes you made to landscapes and climate. Just as you have learned to read the geological evidence left by ancient peoples, those future scientists will piece together the story of your time on Earth. They will see the highways you built, preserved as linear formations of compressed stone and metal. They will find the foundations of your cities, buried but not destroyed by accumulating sediments. Your contribution to this geological story is both individual and collective. As a single person, you add your own small traces to the record, but as part of humanity, you contribute to changes so vast they will be visible in rock formations for millions of years. The agricultural systems that feed you are altering soil chemistry across entire continents. The cities where you live are concentrating new types of minerals and materials in geological formations unlike anything in Earth's past. The transportation networks that connect you to distant places are creating artificial sediment layers that future geologists will recognize as markers of human technological development. But your story is also part of something much older, the same restless human spirit that drove your ancestors across continents still moves through you. The same curiosity that led them to explore unknown territories continues to inspire human exploration today. The same adaptability that allowed them to survive in challenging environments enables modern humans to thrive in diverse conditions around the world. You carry their genes. The DNA in your cells preserves a record of their migrations as clear as any geological evidence. Your genetic heritage connects you directly to people who walked across the Bering Land Bridge, who painted in European caves, who navigated by stars across Pacific islands. The tools you use every day echo technologies your ancestors developed. The steel in your kitchen knives descended from techniques first developed around ancient hearths. The glass in your windows evolved from methods first practiced with volcanic obsidian. The roads you travel follow routes that often trace paths first walked by people thousands of years ago. Your brain carries forward the same capacity for learning and adaptation that allowed your ancestors to survive ice ages and cross deserts. The pattern recognition abilities that help you navigate modern cities are the same cognitive tools that allowed ancient peoples to read subtle signs in landscapes. The social cooperation that creates your communities uses the same human instincts that built trading networks across continents. Even your relationship with geological processes continues ancient patterns. You still seek high ground during floods. You still avoid areas prone to landslides and earthquakes when possible. You still concentrate settlements near reliable water sources. The same geological forces that influenced your ancestors' choices continue to shape where and how you live. Modern humans are creating new types of geological evidence that preserve different aspects of the human experience. Plastic materials will persist in sedimentary layers far longer than the organic materials our ancestors used. Electronic devices will leave distinctive chemical signatures in future rock formations. Satellite imagery creates detailed records of how human settlements spread and change over time. But the fundamental story remains the same. Humans adapting to their environment. Communities forming around shared resources and challenges. Knowledge passing from generation to generation. People moving across landscapes in search of better opportunities for themselves and their families. The geological record shows that this pattern of human movement and adaptation has never stopped. Even after people settled into agricultural communities and built permanent cities, migration continued. Trade routes carried people and ideas across vast distances. Climate changes and other environmental challenges continued to drive population movements. Your ancestors never saw their movements as migration in the way scientists study it today. To them, they were simply living their lives, following seasonal resources, seeking better opportunities, responding to immediate challenges and needs. In the same way, your daily movements are part of migration patterns that future researchers will study. Your commute to work contributes to the flow of people through urban transportation networks. Your vacation travels add to the global patterns of human movement for recreation and cultural exchange. Even your shopping trips create traces that show how modern communities organize themselves around resource distribution systems. The geological perspective reveals something profound about human existence. We are not separate from the natural world. We are part of it. Our technologies and civilizations exist within geological processes, not outside them. Our migrations and settlements follow patterns shaped by the same forces that create mountains and valleys, rivers, and deserts. This connection to deep geological time can provide comfort and perspective. The challenges you face as an individual are part of patterns that have repeated throughout human history. The problems your community confronts echo difficulties that people have successfully navigated for thousands of years. The geological record also suggests reasons for hope. It shows a species that has survived ice ages, volcanic eruptions, climate changes, and countless other challenges. It reveals people who have consistently found ways to adapt to changing conditions while maintaining their humanity. As you settle into sleep tonight, remember that you are part of this continuing story. The same earth that preserved evidence of your ancestors' journeys is collecting evidence of your own life. The same processes that recorded their adaptations and innovations are documenting yours. Your story is being written in stone. Future generations will read it and understand something essential about what it meant to be human in your time. They will see how you lived, how you adapted, how you contributed to the ongoing human adventure. Sleep peacefully, knowing that you are part of a story that began with the first human footsteps and will continue as long as people walk upon the earth. The stones remember everything, and they are remembering you.